was going to ask Brooke, can I ask you a favour? So I'm going to be running the slides this afternoon. Can you keep an eye on the chat for me? Thank you.
Yeah, no
Cheers.
problem.
Okay, so I think people kind of coming in will continue as we go through. I just think in the interest of time, it's probably useful that we get started. So hello, everybody. Delighted to see you all and see so many familiar faces and new faces around the table today. My name's Adam Sutherland. I'm one of the leaders for the Safety Net Yorkshire and Humber PSRC. Yorkshire and Humber PSRC. Oh, I can hear my sorted. Pardon me, Yorkshire and Humber PSRC Human Factors Working Group. I'm delighted to welcome two local researchers from the Yorkshire and Humber region today, Angela and Sam, to talk to us today about their project NG Sure. So NG tube placement is a high risk intervention where a tube is placed through the nasal passage down the esophagus into the stomach, allowing feed and medicines to be administered. Because of our human natural reflexes to protect the airway from the esophagus, these get bypassed by an NG tube placement, and this creates the risk for feed aspiration if the tube is inadvertently passed into the lungs. This is a very rare event, but is catastrophic, and as such is classed as a never event. Conventionally, the only way to test the correct placement of an NG tube is through pH testing of stomach fluid, either on a piece of paper, which fails in up to 2/3 of cases, or with X-ray confirmation, but these X-rays are often misinterpreted. The NG Sure research programme aimed to develop, build and test a technological intervention to resolve this fundamentally human problem. By using sensors to detect volatile organic compounds specific to the environment, the hypothesis of NG Sure was that this system would be safer than established. Today we've got Sam Francis and Angela Grange presenting their work on this. Angela is a registered children's nurse and general nurse qualifying at Great Ormond Street Hospital, London in 1989. She's worked clinically in paediatric, surgical and critical care nursing roles in London and the north of England. She completed her MA at Sheffield and PhD at York, gaining experience in mixed methods research, and has since been working in senior leadership roles in research and innovation in London and Bradford, where she's currently lead nurse for quality and safety research at the Bradford Teaching Hospitals NHS Foundation Trust. Her research interests include NG tube safety, staff wellbeing, second victim support, medication safety, e-health interventions, patient and public involvement and engagement, and innovation in healthcare. Sam Francis is a specialist stroke dietitian at Bradford Teaching Hospital's NHS Foundation Trust with a growing clinical academic focus on patient safety. His work centres on improving the safety and quality of nutritional support, particularly in enteral feeding. He's led service improvement and research initiatives to enhance NG tube safety, including developing and evaluating innovations to support safer placement and decision-making in clinical practice. Alongside his clinical role, Sam has built experience in mixed methods research, service evaluation, and patient-centred safety research. Supported by the NIHR Yorkshire and Humber Patient Safety Research Collaboration, he is developing a programme of work focused on improving safety in home enteral feeding, with a particular interest on workforce models and human factors approaches. And without further ado, I will hand over to Angela to talk about the NG Sure programme. Angela.
Great, thanks very much, Adam. So this is the first time that we've actually presented the entirety of our journey of NG Sure. So I'm really delighted to be doing that for you, and sort of no apology saying that it was a very messy, complicated project. So we want to share with you our kind of real world example of trying to develop a product innovation to improve NG tube safety. And you'll see from this title slide that there's lots of different organisations that have been involved in this project. Could you pop onto the next slide, please, Adam? So this is the plan for our session today. So we wanted to share with you our learning on our developmental journey. We're going to kind of do a bit of a tag team, Sam and I, so we'll be flipping between different objectives. Sam's going to talk about the patient safety problem with NG tube safety, and I'll talk a bit about the design of our innovation, how we involved users. Sam will also talk about some of that. And then I'll talk about how we actually evaluated our intervention, how we tested it clinically, the economic evaluation, and then we'll have time at the end to chat about our challenges, successes, and key learning. So next slide, please. So I guess the first thing to say is it was a really big team that did this project, and although I was the CI and the nurse, I had a superb team around me which comprised clinicians, so I won't go into details of everybody there, you can see, but we had representation from patient safety, from gastroenterology, we had health psychology, so Professor Rebecca Lawton was my boss, we had a statistician, we had subcontractors with the device developers, which was the company called Robo Scientific Limited. We subcontracted York Health Economics Consortium to do the economic component of the research. And just to mention that Lindsay Georgopoulos was our technology transfer lead from Medipec, so she was subcontracted to manage that aspect of the project. So I'll hand over to Sam, who's going to talk a bit about the problem with NG tube safety and the unmet needs, and then I'll follow up by talking about the actual research.
Yeah, thanks, Anne. So I'll just do a little quick introduction of myself as well. So I came onto the project during one of the earlier work packages as a contributor. So I was one of the people being interviewed as a user of nasogastric tubes in a clinical setting. And then it, so conspired that our research priorities were aligned. So we ended up collaborating on the rest of the project going forward. So my background is I'm a stroke dietitian, but I extended my role a good few years ago to manage nasogastric tube insertions and to try and optimize patient safety for patients that have had a stroke and are requiring NG tube insertion. So this project is very much in line with my professional challenges and also passion. So let's talk about the unmet need in nasogastric tube patient safety. So Adam, do you want to? So yeah, the problem. There are at least a million NG tubes used in the UK nationally. Current guidelines recommend using pH as a first line, so obtaining a gastric aspirate and testing the acid level of it. If it's deemed as acidic, we are kind of using that as a proxy marker of an NG tube being in the stomach, which is where we want it to be. However, there are numerous pitfalls for the current testing confirmation methods that we use for nasogastric tube insertion, namely that we can't often get pH gastric samples from NG tubes to test the pH. So I found clinically up to 2/3 of the time we can't even get a pH, so therefore we're referring on for a chest X-ray, so requiring a radiologically confirmed NG tube placement, which costs money, it takes time, it delays medication and feed provision and fluid provision, and it can add to the acuity of a patient's illness. So never events were first talked about from the NPSA in about 2005, and they said that there was at least 53 preventable deaths from nasogastric tube related never events between 2005 and 2016. So if we look at it on a year-by-year basis, it's around 25 to 34 never events per year from people feeding down a misplaced nasogastric tube. And of that, around 5 to 7 of those are because of misleading pH results, and about 12 to 16 from misinterpreted chest X-rays. So people reading an X-ray and getting the location of the NG tube tip, reporting it in the wrong position. So a BBC article in the middle there was a chap, I think was at Burnley Hospital. Honestly, you'd have to read it because I don't want to call out Burnley if it wasn't Burnley. But unfortunately, this firefighter died after being fed into the lung essentially, and ended up in respiratory distress and unfortunately passed away. So although the chance of dying from a nasogastric tube is relatively low, it is deemed something that is wholly preventable. So this is where the problem that we identified needed solving. So thank you. Next slide, please. Okay, so like I just said, the current first line guidance is based on an assumption, essentially a scientific assumption, that if we've got a presence of acid, then that acid has come from the stomach. However, there are reports of acid from the stomach being in the esophagus, and there are some reports of acid from the stomach also being in the airway, unfortunately, due to reflux, regurgitation, medication, and just people that have got different anatomies or different physiological process from one person to the next. So as BAPN say, who are the British Association of Parenteral Elementary Nutrition, an acid pH only shows that aspirate is acid, not where it was derived from. Therefore, it could be a pulmonary replacement, even if we are getting a pH that suggests it's an acidic environment. So although it's a low frequency event, it is often catastrophic and wholly preventable. So we looked at what people wanted. I think this is some focus group analysis from prior to before I was on the project, but Angela and the team looked at some behaviour change work with regards to why aren't people following care pathways for NG tube insertion in the hospital, and people were saying, that we needed a better test at the bedside rather than having to wait several hours for an X-ray, and that people needed a reliable, objective and accurate point of care test to confirm nasogastric tube position. And in a BAPN position statement a few years ago now, although there are some emerging technologies in the field of nasogastric tube safety, they've said that there remains still a significant need to fund research to look at an alternative technique to reliably and accurately detect intragastric placement and exclude the esophagus and or intrapulmonary misplacement, which was one of the key drivers for this project. So our solution was this device on the left-hand side, which is a handheld desktop, well, it's not desktop, handheld VOC or volatile organic compound analyzer. Should we do the next slide? Do you want me to explain a little bit more about what that picture was, maybe? Should we go? No, that's fine. Okay, so current practice. A lot of this, again, is I've already said. So we're looking at needing a pH test, that we need an aspirate from an NG for an X-ray. If we don't have an aspirate, it's possibly unnecessary exposure to radiation often results in delays in giving feed or medicines. It is open to misinterpretation. It increases the cost and ultimately is inconvenient and possibly still not the safest way of managing nasogastric tubes for our users. So our solution was looking at something that didn't require an aspirate, could reduce unnecessary X-rays significantly, that we could initiate treatment quicker, It was low cost and improved user or patient experience. Ultimately, didn't change current practice because we know how difficult it is to convince clinicians to change the way that they're working, even in the face of obvious evidence that things could be better. So we looked at volatile organic compounds as an emerging diagnostic method. So I am not a biologist or scientist by background, so I'll do my best to translate this science for you. But ultimately, VOCs are gaseous molecules that can be sampled quickly and non-invasively. So they can either be found within the body or externally through diet, prescription drugs, or environmental exposure, or paint cans I've noticed recently. Say a lot about VOCs on there, but essentially there are different VOC profiles in different places within different chemical makeups within or outside of the body. So VOCs in exhaled breath, they've been used recently to study asthma, lung cancer, and it got a lot of exposure during the COVID-19 pandemic, looking at non-invasive ways to confirm or to rule out people that may or may not have had COVID-19. So the main thing here is that the use of volatile organic compounds is a potential, as there is some strong evidence that suggests that the type and concentration of different VOCs differ across stomach, lung, and the esophagus as anatomical locations. So our design concept was, can we use VOCs obtained from a nasogastric tube, analyze them with a VOC analyzer, and ultimately distinguish between different anatomical locations as a marker of nasogastric tube position? So our question was, can we offer a non-invasive method for differentiating anatomical location, providing a promising patient safety solution? So our research, is this one yours, Ange?
Yeah, that's over to me, Sam. Thank you. So if we could go to the next slide, I want to give you the kind of chronology of how we even got to start doing this research. And actually, it's looking like 10 years ago we were doing this work. And we found out about VOCs as a potential idea because we were linked to a company through the innovation department at Leeds University when we were doing our behaviour change work to look at why aren't clinicians following first-line testing for NG tubes. So it was a bit sort of serendipity, really. And the company that we worked with had never done research in the NHS before. They'd worked in the agri-food industry, but we got together and we did some sort of early sort of feasibility testing, which was before we got this big grant from the MRC and the Development Pathway Funding Scheme. So we recruited some patients and we collected samples down a gastroscope. These were elective patients, and we used a benchtop analyzer, which was quite a big piece of equipment, just to test the concept of can we measure VOCs down a gastroscope. And we found out that we could, and we also did further studies to kind of look at developing chemical sensors that would measure these VOCs, and to sort of give you an idea of the funding sort of route, we did put in a bid to NIHR Eye for Eye funding scheme and got to second stage, but unfortunately we're unsuccessful, but used some of the feedback and did this further clinical study to provide some more kind of evidence, which I think definitely helped us in our funding application to the MRC. So that funding application went in 2018 and was approved then. And it was a 3-year project which comprised 5 work packages. And so you've seen the team of people on an earlier slide that was involved in the team, the co-investigators. I was leading as chief investigator. And the premise, as Sam was saying, was that we wanted to see if VOCs could be a marker for NG tube tip location. And we were thinking that were the VOCs different according to whether a tube would be in the lung or the esophagus or the stomach, and we thought that we could produce fingerprints, if you like, of those VOCs readings. And as part of our bid, we had to do a competitor analysis to kind of demonstrate how our idea was different to what was already out there in the marketplace, as it were. And so our aim was that we were going to have 2 markers for tube position. We were going to look at VOCs, but we were also going to develop a pH sensor, because we recognised that that was what was in the clinical practice guidelines. And so our aim was to, working with this company, was to develop a prototype device that we could then test on actual patient samples. And what it was supposed to be a 3-year project, but actually ended up being 5 years, and we'll explain why that was so. Next slide, please. Don't know if it's moved on.
Is it on the MRC funding award slide?
Yeah,
It's on the next, yeah, so I'm still on the funding awards slide. So the next one is the programme of work.
Oh, okay.
That's it, yeah. So that's a bit more detail around each of the 5 work packages. So our first work package, we were trying to develop, there were 2 pieces of work going along. We were trying to develop the sensors that went in the device to measure the VOCs, as well as doing the clinical research to collect the samples. The second work package was looking at how can we get the sample up the patient's nasogastric tube that we want to test, and I'll explain later that what was our original design concept that we presented to the MRC actually changed quite substantially from what we thought the design was going to be, and I'll explain the reasons for that. We had 2 studies in our user-centered design aspect, and that was kind of informed by the MPSA guidance on developing a medical device. So we had 2 studies, one looking, exploring with users the features and characteristics of the device, and then the second was simulation testing. Then once we'd got our kind of product, we wanted to test it in the real world, and to test it on patients to look at accuracy and the clinical utility, because we wanted to develop something that was going to be acceptable and could be used in practice by clinicians. And then throughout the whole of what was the original 3-year plan, we had work package 5, which was led by our technology transfer representative, which was Medipex, and that was dealing with all the governance, the regulatory affairs, navigating the device regulations, also looking at the economics evaluations, which the York Health Economics Consortium did, which was budget impact analysis, and looking at how we might potentially commercialize this product. And part of the whole bid to the MRC was not only kind of doing all the competitor analysis, explaining why our product was going to be different and to what was already out there. It was how are we going to develop it, and then what were our plans to go out to market should we get to that point if it evaluated well. Next slide, please. So I'm just going to go briefly through each of the work packages. So we were essentially trying to miniaturize what was a benchtop VOC analyzer that the company RoboScientific that we were working with had developed. And to do this, we needed to develop miniaturized sensors and to test those on VOCs that we were collecting from patients. So this study was a bit of a repeat of the earlier studies. So we recruited patients that were referred for elective gastroscope, and we collected samples up the gastroscope, air samples and gastric samples, and analysed those with our sensors to look for VOCs, and we were looking to see if the profiles were different according to stomach, esophagus, and also collecting breath samples from patients, so a bit like a breathalyzer kind of test. And so there was a lot going on in that study, and we had the support of the gastro-clinical research nurses in the trust to collect that data. So that was the first study. If we could move on to the second one. So our original concept was to have a closed system. We thought that our idea was that we'd collect our device to the end of a nasogastric tube, and that we'd be able to sample an air sample up the nasogastric tube, which our device would analyze. And you'll see as we go on that actually wasn't possible to achieve for many reasons. But we needed to check that actually could the sampling process work? How were we going to get this sample up the nasogastric tube? We'd ruled out the fact that the device was going to work like a pump and suck up the air up the nasogastric tube. We couldn't do that. The infection control regions, and also it was really challenging to engineer basically a practitioner using a syringe on the end of a nasogastric tube and having that kind of control over collecting that sample. So we had to engineer an interim step, but first of all, we needed to check, could we actually get VOCs in these samples, and could we get the right volumes of air that we needed to run through our device? So that's what the second study was about, and we were able to achieve that. Throughout the whole project, we had all these milestones that we had to achieve through our funder in order to progress. So that was another milestone that we had to get through. We had many conversations with users of NG tubes, which was the third study, and we'd done some focus groups before this grant. And the predominant users of NG tubes are NHS staff, although there are some patients out in the community with NG tubes. We focused on the staff perspective, but did get one view of a carer. And there were two strands to this work. So we wanted to understand what users' needs were. We wanted to actually look at what real life practice was in the NG tube pathway. So we did some observations in practice, and that helped us to understand what the risks were, what workarounds were, and the sort of error-prone processes to help inform our design. Can we move on to the next slide? So the first user-centered design study, we were hit by the pandemic like many researchers and had to completely change the design of our studies because of access to staff and not social distancing. We were going to do focus groups with staff to get this data, but we couldn't do that. So we did one-to-one interviews, and we looked at who we felt were the users of NG tubes, and we interviewed 18 staff, one carer, and these were the sort of we wanted to get a variety of roles and grades of staff. So you can see we've got dietitians, we've got engineers in there because it's important to get the perspective of the people that are going to maintain a future device, as well as many nurses actually and doctors. And they were able to tell us what they would want from a device, what the features and characteristics should be. So for example, things like the size of it, how heavy it should be, how it should be powered, what it should be made of, because we have to comply with infection control procedures, and information on how they would want information being displayed to them, in what would be helpful. Did they want sounds and noises as the sample was being analysed? How did they want the information displayed on the screen? And all that information we compiled into a report, which we were thinking could be used for a technical file should we then go on to the next phase or get going into manufacture. We did observations in practice, so our senior research fellow shadowed practitioners on the ward and looked at the process of NG tube insertion and testing. And we worked with our economic economists, our health economists, and had a performer where we collected economic data. So we were looking at who's putting tubes in, how long is it taking them, who's involved, does the patient go for x-ray, just so we can get an idea to build up our cost consequence analysis and budget impact assessment. Next slide, please. So these were our sort of key findings from the interviews with staff. People wanted a simple, I suppose it sounds pretty obvious, people wanted it to be a simple process with how they collected the sample and analysed it, that didn't require a high cognitive load, because healthcare professionals are working in very demanding clinical environments. It just needs to be an easy process. They wanted it to be really clear-cut how information was displayed as to whether the tube was in the right place or not, whether it's safe or not safe to use. And they wanted something that could be used at the bedside, that was portable and durable. And I think what was interesting when we thought we were going to have a device that was connected to the ends of the tube, it became obvious when we talked to users that actually you're going to need two people, because you can't hold a device and insert a tube at the same time when it's on the ends of a tube. So actually the change in design ended up being beneficial to us in a way, because it meant that our device could just be used by one person and not two. We felt, and this came over quite strongly from users, that some innovations are really disruptive and others aren't. And I think what was clear from users that they wanted something that wasn't going to really interrupt the existing pathway too much, because it would be more likely to be adopted and implemented in practice. They shared with us kind of what the risks were, and came up with lots of challenges about what if the tube is in this position, and lots of questions for us to think about as developers. And then they were able to sort of identify gaps in current practice too. So they were the key themes. Sam, I'm going to hand over to you for the second user-centered design study.
Yeah, so work package 3B is kind of where I became a lot more involved in the project and increased my non-clinical time as a stroke dietitian and increased my time as almost a proxy researcher on this study. So work package 3B was focusing on evaluating and refining our prototype through simulation and real world testing. So I was taking our prototype to practitioners on the ward and running, giving them instructions and seeing how they behaved with our prototype essentially. So we were looking at assessing its usability and the user experience to identify risks, limitations, and opportunities for improvement. We did simulation testing to evaluate interaction, workflow integration, and potential use error. And we wanted to look at iteratively refining the NG Shore prototype with this in mind. So there's a significant difference between sitting and interviewing people about a possible device they might use in the future and actually engaging with somebody with a prototype device and seeing how they feel with it in reality. So ultimately, we tested it with 21 NHS staff using simulations in a ward environment. So this is where it really helps to have someone with a strong clinical link, I think, within a research team in this type of project, because I've worked within the trust now for nearly 10 years on numerous wards, and it was quite more straightforward, let's say, and I have the relationships and networks to be able to approach people and say, we're looking at doing this, are you interested in getting involved? And it possibly ended up resulting in having more people that were willing to get involved in the simulation testing. So we observed these 21 staff members using something called Think Aloud, where we essentially get them to talk through their thinking, talk through their actions, and write notes as researchers of some of the comments that people might be making. Like, for example, if they were trying to fit the bag to the end of the tube, so, oh, this is a bit fiddly, or, when they're saying things out loud, it gives us a real insight into what they're actually thinking rather than us just observing their physical behavior. So they used an SOP, standard operating procedure, independently, and then reflected their real world use, which took about, well, between 4 to 20 minutes. And the sample analysis time for the actual mock sample we provided them with was only 1.5 to 2 minutes per test, which was well received. Next slide, please. So essentially what we found was people felt that the device was easy to use, it was intuitive, they could kind of follow it step by step using the guide, and also the responses that the machine provided them. So they felt it had a high usability and a high user satisfaction rate. They felt that it would reduce reliance on error-prone processes, such as reducing the need for x-rays and subjective interpretation of them, and also pH strips as, you know, towards the cut-off point between the higher end of acidity, so lower end of alkaline. Some of the colours on pH strips can be quite hard to differentiate. So people felt if they took that out of the equation, it's less so reliant on them interpreting a colorimetric strip compared to a machine saying yes or no, essentially. So the design feature supported safe use. So there was some clear buttons on there. Everything was cleanable and adhered to infection control policies and procedures. And users highlighted the need for clear feedback, so fail states or sampling success or attempts, whether or not an attempt has been successful or not. They felt it strongly aligned with clinical workflow. It could add into the pathway, so essentially they'd try and get an aspirator bedside. If they couldn't do that, then NG Sure could then step in as a step between not being able to get a gastric aspirate before having to request a chest x-ray. And they felt willingness to use it, so people wanted to use it. They wanted it to be successful, and they were quite keen to see how it would develop in terms of an innovation, a clinical innovation. Thank you. So after work package 3B and getting simulation testing, finding out what people, how people felt using it in a proxy clinical environment, we looked at testing proof of principle and feasibility to see if we could actually use this machine under, you know, real life environments rather than a lab-based setting that we'd used before, or samples obtained from other interventions such as gastroscopy or bronchoscopy, and to see if we could get VOC samples from fluoroscopically guided nasogastric or nasojejunal tubes from patients undergoing X-ray placement of an NG or an NJ tube over at Leeds Teaching Hospital. So we wanted to assess the feasibility of sampling. So if we could see if we could get a sample from the esophagus, the two places in the esophagus, so upper esophagus, lower esophagus, and then one from the stomach. And hopefully if we could measure the VOCs from those samples using NG Sure, so using the prototype device that we've designed, and evaluate ultimately the ability to classify those samples as stomach versus non-stomach, and therefore support clearer user independent decision making. So it was quite not as smooth as one would have hoped recruiting patients over at Leeds Teaching Hospital for a variety of reasons. So unfortunately, we ended up with less participants than we initially wanted, and we got 12 in the end, so 8 male and 4 females, and mean age was 57, you know, plus or minus 14 years. Most of them were white British, a mixed smoking history, and then the main indication for their tube insertion was pancreatitis. So we managed to get 23 valid samples from 10 patients, so 7 of them from the upper esophagus, which was sort of clavicle notch region, 7 from the lower esophagus, which was just above the gastroesophageal junction, and 9 from within the body of the stomach. And out of the 10 patients we managed to get samples from, 5 of them we managed to get a complete set of samples from, so 3 samples from each anatomical locations that we were trying to get. So we found it difficult in that there was significant resistance getting air samples from esophageal versus gastric locations, and this was from consultant radiologists that were completing the fluoroscopically guided NG tube insertions, and that the air and fluid volumes varied by anatomical location, but also from person to person, depending on what their clinical condition was, medication that they'd had. And ultimately, it was a lot more complicated getting samples from a tube, significant air samples from a tube than we had anticipated. However, from an acceptability standpoint, it was well tolerated and there was only minimal patient discomfort, and 1 patient said that they felt it was significantly too uncomfortable, but the rest rest of the patients felt that it was absolutely fine. So from our sensor outputs, we detected VOCs in all of our samples, which was amazing, which with a distinct sensor response. So the sensors were basically measuring divergence, so like an electrical signal change depending on the VOC concentration. So the higher amount of VOCs, the higher that divergence response. And 16 out of our 23 samples correctly classified as stomach versus not stomach. So there were some modelling insights from statistical analyses, of which I am underqualified to truly talk to you about. However, we did some dimensionality reduction and multiple models, and we looked at ridge regression, so UMAP approach, but results were uncertain, and we didn't have enough of them to predict overall performance.
Got about 5 minutes left. You're doing really well. Good timing.
Thank you, Adam. Next slide. So key limitations from work package 4, so testing proof of principle. So we haven't currently classified, optimized our classification threshold. So the software within the actual prototype itself, the company that we're working with, RoboScientific, it was quite an arbitrary pass-fail software. So it was based on some lab samples that we did, numerous amounts. However, it would need testing significantly with real live human samples from known locations to truly write the model to safely use the software within the NG Shore to differentiate between stomach and not stomach. There was overlap in some responses between gastric and non-gastric samples, and the actual statistical modelling was a challenge because of the small sample size and high data complexity.
Thanks, Sam. So quite challenging the last the kind of testing the prototype, and we can give you more details around that if you have questions. But work package 5 was this sort of intellectual property commercialization piece across the whole 3 years, and actually sort of one of the challenges with getting this grant from the MRC was that it was a requirement to have all the IP collaboration agreements, subcontractor agreements in place before we actually started. So it took 10 months to do that. And I needed a lot of support to get those in place. But so that was one aspect of the IP. Obviously, the user-centered design, we developed this kind of technical file, and we got the information from the users, which would be helpful for any company that may want to look at developing an NG tube testing device and to use for future development. And I think it's fair to say that the simulation testing methods that we used were really effective, and the kind of qualitative approach with the thinking aloud worked well, and we had really positive feedback from staff. I think, you know, what was a real plus on this study as well is that we'd had considered the economics. So YHEC were able to develop a kind of cost consequence model where we could put in various permutations and scenarios to look at, should NG Shore be implemented into the NHS for this scenario? Is it going to be cost effective? And so we could look at if it was going to completely replace current forms of NG tube testing, or if it was going to supplement, and how much that would cost. So that was a really helpful exercise. Next slide, please. So we've tried to focus on the human factors element of NG Shore. There's a huge amount of work that was done over the 5 years, but I think sort of in summary, we hope we've shared with you the kind of systems related challenges around confirming NG tube position, and shared with you our approach to user-centered design involving NHS staff. Our solution was trying to be objective. It was trying to look at safety and accuracy, and to limit sort of subjective interpretation. It's fair to say that it was a really iterative process, and we'd built in our design points where we would build on user feedback and make changes to the design, but we weren't able to make all of those changes within the time frame, but we've got that information there. We attempted to do, our original plan was to do a first-in-man study with 200 patients, but as the project progressed, that wasn't going to be possible to achieve, and our outcome measures changed, so we had a much smaller study. But I think we have generated some evidence on feasibility. I think we've provided the first evidence on whether VOCs can be measured from air samples from an NG tube, and we've tested whether it's feasible to even get an air sample up an NG tube when the tube's in the esophagus or the stomach to put through the device. So I think there were, although we hadn't got to the end of developing a product that we could take to market, we had generated some useful evidence, and particularly around the user-centered design, and also around views around implementation and the economics. So next, I think we're now to the final slide. So sort of in summary, the human factors approach has enabled us to come up with a usable and acceptable design, but I think we clearly need to do more research because our sample size was small in the final study. So we haven't got enough evidence to sort of take this product to market in its current state. So that's where we got to, and be very happy to answer any questions, because I realise that we've whizzed through sort of 8 to 10 years work in 35 minutes. And there's the next slide has just got our contact details on.
Wow. Thanks so much, Angela and Sam. You're right, just potting 10 years of hard work, tears and agony into 40 minutes of presentation is absolutely fantastic. But to me, kind of what came through there, what burned through there was just how important the ergonomics and human factors of this issue really kind of sang true into that. So what I want to do is, first of all, give you a round of applause. Thank you so much for coming and presenting to us today, and I'd like everybody else show their appreciation. And then I'd like to throw open to questions from the audience. If anybody has, just raise your hands, or if you want to drop something in the chat, that's absolutely fine. Around for some hands. So while people are thinking of their questions or trying to frame things, I suppose, Angela, what you've presented today is an absolutely amazing example of the messy reality of technological innovation in healthcare. What's the biggest lesson that you think you've learned through the NG Sure project? What's your biggest reflection?
It's been such a journey, because I went into this not knowing anything about how to develop a product, not knowing anything about regulation, not knowing very little about user-centered design, to be perfectly honest. But I've sort of jotted a few things down that sort of sprung to mind. So my biggest lesson, I think, is having the right people around you when you're trying to go on this journey. So you'll see from the team, it was a real mix of disciplines. And I think this was my first major grant as chief investigator, £1 million. And I felt that a lot of the team were more eminent sort of scientists, clinicians and academics than me, but it was sort of having the confidence to ask for help and to rely on that expertise when I needed it. I think I learned that the MRC is a very supportive funder, and I learned that actually not to be afraid to tell them when things aren't quite going the way that you hoped. And obviously our concept when we applied was very different from what the end product looked like and how it was going to work. But I think being honest with the funder about the challenges was helpful, and they helped me to work through solutions. They were trying to be supportive. I think in terms of the device development, that was really challenging, because we were working with a company that worked in the agri-food industry, that hadn't worked with human beings, hadn't worked in the NHS. And I think if I was doing this again, it's just understanding when you're working with industry, how that company operates, being very clear about expectations and roles and responsibilities. And I've learned the importance of relationships and the importance of having to negotiate, communicate often. And I shouldn't really forget the importance of users, because they're key. And I think that's the biggest lesson, actually, is involving the user, the people who are going to use this device in practice. They're the people that you want on your team. People in the NHS know what they need to do their job, and they know the challenges, and there was a real energy and enthusiasm to work with me on that. Yeah, so that's quite a long answer. There wasn't one big thing. There were lots of things.
So the importance of collaboration, the importance of understanding everybody else's perspective, and that really important support that you got from your funder. I think those are kind of the takeaway.
And the team around you, and yeah, and just and seeking that help, because we were working in a area where nobody in the team had done anything like this before, so it did feel like you were stumbling along a bit blind a lot of the time, but got there in the end.
Thanks. And then Sam, I think something a little bit more kind of anatomical. So a big part of human factors is understanding kind of how our bodies influence the way we work and the way things function around us. What's missing? Given that you were unable to, we found it really surprising that you were unable to get air aspirates, liquid aspirates from the GI tract. What's missing in our understanding of the GI tract and those sorts of factors that might help inform onward development and improvement of this in the future?
I think it's how different parts of the esophagus behave under different conditions, really. So even the lead consultant radiologist Damien Tolan over at Leeds, who's done loads of work on the NG conformation pathway with X-ray, it was always very much like we want to blow some air down the esophagus and see if it stays there. What do you think? And he said, well, I have absolutely no idea. Presume it will, or presume it won't. So part of this testing was actually really just to find out how the insertion of air, or trying to get air out of the esophagus, which is essentially just a tube from one place to the other, how that actually behaves in reality. So more testing with regards to feasibility and how do we view what's going on under imaging of some kind. So if we were putting air down the esophagus, we couldn't see it on X-ray, so we didn't know if it was still there or what air we were pulling back. So some studies looking at that would be really helpful. I think, as we'd said previously, if we could get a machine that attaches directly to the end of a tube, I think that would take out a lot of the sort of interim stages that might have made obtaining our sample or keeping our sample easier. So I found if we were getting air from the esophagus and then putting it into our sampling bag, and then from the sampling bag into the machine, how much of it was left by the end, we don't know, because we couldn't see it. You can't see it, it's air, isn't it? So
yeah,
and that was a challenge. So there's obviously some clear things to understand with how our upper GI anatomy works from an air, and how it holds air, especially with regards to volatile organic compounds.
Okay. Thank you very much. So we've got one more question in the chat, which I'll take as the last question, and then we'll wrap up. So from Alison Bravington, complimenting you on what an amazing piece of work this has been, and how unfortunate it was that you stopped before the vision was fulfilled. So Angela and Sam, what are your next steps, and how kind of what are your plans to kind of move on from this project and continue the development?
Yeah, so I guess, we didn't get to where we hoped to be, because in the grant we had to describe what our ongoing plans were around commercialization, but we hadn't got enough evidence really on the prototype as it stands. So kind of working with Medipex, we were thinking, could we needed to really work with another company probably to take this forward, and so we tried to do that. So we tried to identify global players in this field, and we did do a pitch to a company, but unfortunately, although they really commended us on our kind of trailblazing work, actually, they were very complimentary about the rigor of our work and what we achieved. I think they felt it was so early stage, it was going to require quite a lot of investment. So I think we're at a bit of a crossroads, to be honest, about what to do with this next. I still really believe in it. I really believe in the concept of it, but I'm not really sure the chemical sensor VOC technology is the way forward with this. And I should sort of add that in the final work package, we started to seek another, to see if we could find another company to work with. And we did identify a company that measured VOCs using a different technology, GCMS, and we'd got them involved, we'd got them in on our ethics submission for work package 4. We were going to test our samples in their technology, which admittedly was a benchtop analyzer, but unfortunately that company went into financial difficulty and had to withdraw. And so in a way, but giving you a really honest account, that was potentially our exit strategy, to work with another VOC developer to see is there a better VOC technology maybe to take this forward.
Sure.
But it's left us with questions around, actually, can VOCs be used in other contexts and other applications? So, for example, detecting if a patient's dehydrated, detecting if there's infections. So I know that VOCs have been used to detect appendicitis in children because it's really difficult to diagnose. So this technology is being tested in this way for that problem. So I think it's not the end, but I'm not sure where to next, to be perfectly honest.
No problem. Thank you. Sam, you had your hand up a minute ago.
Yeah, so I think if you look at the evidence base, there is a strong evidence base for using VOCs as a non-invasive diagnostic marker for a variety of conditions. I think what we need to do, I think, going forward from a nasogastric tube perspective, is to almost strip it back again and almost go backwards, and to look at, can we do this in a slightly different way? Can we use it, like Andrew said, like a different company or a different instrument, or can we be a little bit more robust in some of our procedures to make sure that when we are getting VOCs from somewhere, we know where it's from and exactly what those VOCs are. I think it's very much in its infancy, this type of technology within nasogastric tubes. And I think in the future, we'll start seeing VOCs used for a whole manner of different diagnoses, and showing different anatomical locations is not out of the question for that. We just need somebody with big pockets and a bit of patience, essentially.
Bit more investment, and that will show you the way. Absolutely.
I think so, yeah.
Fantastic. But yeah, an absolutely brilliant piece of work, and so interesting listening to you both talk about your experiences here. I hope everybody in the audience has got some things they can take away from this. I'm going to take away around cognitive narrative explanation, that think aloud, talk aloud of what people are doing as a way of understanding why our work is done is different to our work is imagined. That's going to be one of my big takeaway methods for my work in the future. But for now, thank you, Angela and Sam, again for your time and effort this week today in presenting your work to us. Thank you to everybody in the audience for joining us this afternoon. Appreciate it's a busy time of year for many of us. It's lovely to see so many of you, and again, so many familiar faces. But for now, thank you so much for your time. Have your Thursday afternoons back. It's been lovely to see you all. Best wishes for the summer, and we'll see you soon. Take care. Bye-bye.
Thanks, Adam.
Thanks, Adam.
Okay, how did we think that went? It's one more person, so I'm just gonna
Do you want to stop the recording as well, Adam?
Oh, I'm not recording it. It's Sadia.
She's gone now, hasn't she? So
Yeah. Oh, has she? Can I stop? Oh, yeah, I can stop the. No, I can't.
Oh, should I just email?
Can someone
Oh, no,
Teams
hang
or
on.
say,
Is
can
there
you
a
stop
way
the
of
record?
stopping it?
Just that we can clip it.
Yeah, that's fine. We can edit.
stop
Oh,
recording.
that was really good. That was
Wait,
so
wait.
interesting.
Mm.
I've stopped it. The recording.